2.5b, tangents of circles. So a tangent intersects the circle in exactly one point called the point of tangency. So here, this line RS intersects the circle at R. So R would be considered a point of tangency. A tangent line is perpendicular to the radius. So I have a radius at PR, and that's a tangent line. So that means that this line right here is perpendicular. That's why you can see that 90-degree mark. And tangents that share the same exterior endpoint are congruent. So RS is a tangent line, TS is a tangent line, meaning that those two segments would be congruent to each other. All right, example 1, AB is tangent to circle C, find X. Well, again, we just learned a radius is perpendicular to that. Now I have a right triangle, and when I am missing a side length in a right triangle, we use Pythagorean theorem. So a squared plus b squared is equal to c squared. My C needs to be my hypotenuse right here. So AC is considered my hypotenuse, but I am missing part of this. However, C to D is also a radius. So C to B is a radius, C to D is a radius. So this side length right here is 8. And if I add them together, that becomes 17. So now I have a side length of x squared and 8 squared, and then 17 squared. So now I can solve this. So x squared plus 64 is equal to 289. Get x squared by itself. So x squared is equal to 225. Take the square root, and x is equal to 15. Example 2 is pretty much the same idea here. We are still taking CA to be our hypotenuse, except the length of our hypotenuse is x plus 16 here. So a squared plus b squared is equal to c squared. A and b are just our sides of our shape, so this can stay as x squared plus 32 squared. And then c squared is x plus 16, so x plus 16 squared. Notice how I put x plus 16 in parentheses. It is also not x squared plus 16 squared, so please do not tell me that's x squared plus 16 squared. Remember, squaring something, you are multiplying it by itself twice. So this becomes x squared plus 1024. And I have to multiply this out. So this becomes x plus 16 times x plus 16. So x squared plus 1024 is equal to, take it one step at a time, so x squared plus 16x. And then do the same thing with that 16. So plus 16x. And 16 times 16 is 256, so plus 256. Combine like terms, so x squared plus 1024 is equal to x squared plus 32x. 16 plus 16 is 32, plus 256. Now, because I see an x squared term, I'm tempted to factor, so let's get everything onto one side. However, when I do that, my x squared terms actually cancel out, and I'm left with 1024 is equal to 32x plus 256. So now I can just go ahead and solve this. So I get 768 is equal to 32x divided by 32. X is 24. All right, in example 3 here, I see that we have two tangent lines. So JK is tangent, JM is tangent, and they're both sharing this point J right here, meaning that these two segments are going to be congruent. So I can say that 2x squared plus 3x minus 2 is equal to 3. And again, I see that x squared, so I'm going to factor it, subtract 3. 2x squared plus 3x minus 5 is equal to 0. X squared, we have an x squared term, so I have to factor. Because we have a coefficient in front of that x squared, things change a little bit, not by much, but they do change. So first I'm looking for factors of 2. Factors of 2 are only 2 and 1, so it has to factor into 2x and x. Now, factors of 5, 1 times 5. I need to make a 3x. There's no way out of 1 and 5 I can make a 3x. But remember, these two outside terms we multiply together. These two inside terms we multiply together. You have to factor this by a method that we call guess and check. So if I put a 5 here and a 1 here, 2x times 5 is 10x, and then 1 times x is just 1x. Out of 10x and x, there's no way that we can make a 3. So now I know that that way doesn't work. Let's go ahead and check to see if another way will work. So now I'm going to flip these two. So what if I put a 5 here and a 1 here? 2 times 1 is 2x. 5 times x is 5x. Out of 5x and 2x, can I make a 3x? Yes. Positive 5, negative 2. 5 minus 2 gives me a positive 3. So this needs to be positive, that needs to be negative. So I have it factored, but my next step is I need to set each of my factors equal to 0 and solve. So 2x plus 5 is equal to 0. 2x is equal to negative 5, and x is equal to negative 5 over 2. And then I have x minus 1 is equal to 0, so x is equal to 1. Number 4, example 4, determine the perimeter of triangle ABC if circle O is inscribed in the triangle. So there's that word inscribed again. All it means is that all of the points of my circle are lying on the triangle. Now they're inscribed. So for example, if I look up here, BE, this is a line of a tangent line. BD is a tangent line, and they're both sharing B, which means they're congruent to each other. So BE is 6, DB is 6. Same thing here. AD is a tangent line, AF is a tangent line, and they're both sharing A. So if AF is 12, A to D is also 12. Then F to C, tangent line, E to C, tangent line, they're both sharing C, so this side right here is 8. Now to find the perimeter, I have to add up all the sides. So 6 plus 8 plus 8 plus 12 plus 12 plus 6, and my perimeter comes out to be 52.